All right. So yeah, my first instinct here would also be to subtract 7. If I tell you to solve, we're going to minus 7, minus 7. It's going to give us 3x equals what? Negative 2. What do we do next? That's so crazy. Oh my gosh. Divide by 3. I know, I was adding commentary to a conversation that's off topic to try and get the off topic conversation to stop. There we go. Negative 2/3. What was the goal there? What did we find? What does it mean for us to solve stuff? Yeah. We got x by itself. So our goal when we're solving, whenever it says solve, thank you. Whenever it says solve, that means we want to get to an x equals. That is our whole goal. So when we have something like this next one, we want to get x by itself. So what can we do? Eventually, but I don't want to square root it now because it's going to give me a square root of 3, which is objectively horrible. Let's add 5 to both sides. That is absolutely a valid option. We can solve, that's called solving with square roots. Not our only option, but definitely a good one. And very familiar. So we're going to have 3x squared. When we add 5 to both sides, we get 12. Then what should we do? If I square root it right now, let's divide by 3 next. So here we go. Let's try that. So that gives us then x squared equals 12 divided by 3 is 4. Now what do we do? Square root. So what does x equal? 2. Is there another option?
Yeah.
What?
You can, it's the way I was just thinking about doing it too.
What else, when squared, is 4?
Can you say that one more time?
What else?
16.
That would be 4 squared. So what else, when squared, when times by itself, gives us a positive 4? 2. And something else does as well. 2 squared.
Like something times by itself.
Uh-huh.
That's 4.
Yep.
With the same number?
Yep.
Oh, negative 2.
Yeah. 2
Oh.
and negative 2.
Yeah.
Negative 2 also will make 4 when it's squared. So we do negative 2 times negative 2 is going to be 4. So whenever we do it like this, where we do square roots, we're always going to put plus or minus. Or you can write them out. We can do x equals 2, x equals minus 2. Because whenever we have a squared, more often than not, we're going to have 2 answers. There are times when we're only going to have 1, but more often than not, we're going to have 2. So if we just have an x squared and no x, this is a valid option. We can absolutely do it this way. We can get our x squared by itself, square root both sides, put a plus and minus. What if we have something like this? Do we have any like terms to add?
No.
No. So always a good idea to check.
Get x by itself.
Get x by itself. How
Add 9.
is that going to help us though? Because we got a couple x's over here.
Subtract 42x.
Would that help?
No.
I mean, you can do that all you want. not going to help though. I think we should keep it set equal to 0.
Oh, then x squared, move that, wait, no.
Wait, you talking about, how do you make it?
How could we solve this?
You could, factor?
Wait, let's see if we can factor it. So option 1 would be to try and factor. Because when we have it in factored form, those roots, those x minus r, those are our solutions, our zeros, our roots, our x-intercepts. So let's see if we can factor this. That's when we take our a times c, 1 times negative 9 at the top, our b at the bottom of 42. Is there a pair of numbers that multiplies to make negative 9 and adds to make 42? Think through the things that multiply to make 9.
9. I was 3 or 6. No, that's 3.
So things that multiply to make 9.
3 times
1 and 9,
9.
3 and 3,
That's it.
and that's it. Do any of them add up to 42? So is this factorable? Gross, right? So if it's not factorable, and we can't solve by square roots because I don't have a square root here, gross. We have 2 other options, but one you've probably never done before. One you have. And we hate it, but we can do it. The quadratic formula. Which you don't have to have memorized. I will always give it to you if you need it. Okay? So if it's not factorable, probably our second instinct is going to be to do quadratic formula. Which I'm just going to write quad formula because I'll spell quadratic wrong. So we're going to have, that's our x equals, and I can always pull up the videos. There are so many videos on YouTube of people that make songs to help you memorize. One of my favorites is a Dre song. They are a special kind of bad. Like, if you need a giggle, go on YouTube and find the quadratic formula songs. They are, some of them are just epically bad. So x equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. There's some that involve dances. There's one that's a couple of little white girls in their backyard doing a Dre song. There's one that's Superman. X equals negative 2a. 2a. Like, it's a whole thing. It's a whole thing. It's very obviously some teachers that give extra credit for making a video for that. They're high quality. So if you need a giggle, go look for the quadratic formula songs. They're epic. So what we're doing here is we're going to take our A, B, and C values here. What are our A, B, and C values? 1, 42, and negative 9. So make sure we pull the signs. So we could absolutely do this in the quadratic formula. There is another option, but it's probably not a direction you've ever solved before. But honestly, I think it's easier than the quadratic formula, but slightly more annoying than factoring. And that's putting it into vertex form, because then you can solve it with square roots. So not a common option, but it is something you can do. If you're headed into vertex form anyway for something, that's a fine way to do it. But let's just do this one with the quadratic formula. So I'm going to go down. I'm going to give myself some more space. So we are going to do this. We're going to type this in. We're going to put this in the calculator because I want us to practice that. So x equals the opposite of our b, 42, plus or minus the square root of b, which is 42, squared minus 4 times our A times our C divided by 2 times our A. So we're just plugging things in. And I, in fact, will almost always color code like this so that I can help spot that I've got everything plugged in correctly.
You remember the two-way song?
Huh?
The two-way song?
Two-way. When I first found that one, my youngest was about 4, and she walked around the house for 3 days going, two-way, two-way. They're now 10. All right, so when we come to simplify this and try and figure out what our x is, what our solutions are, we're gonna do it in chunks and not type the whole thing into the calculator. We can't type this in anyway. So we're gonna have our negative 42. We're gonna do 1 with a plus, 1 with a minus. And I'm gonna simplify this piece. It has a name. I'm never gonna like quiz you on the name of it. It's called the discriminant. So if you ever look up stuff about like any of the homework and you see a funky word, that is the piece called the discriminant. So I'm gonna simplify that. We're gonna do our 42 squared minus 4 times 1 times 9. And we're gonna type that in our calculator. 42 squared minus 4 times 1 times negative 9. And we get 1,800. Whoa, that's not a pen. So we're going to need to type this into our calculator a couple of times. So we're going to have our 42 plus the square root of 1,800 over 2, and we're going to have negative 42. Okay, what am I writing here? Let me fix that. Pen. X equals negative 42 minus the square root of 1,800 over 2. So here's another time what I mean. We're going to have 2 answers. We're going to type it in twice. So we can do it in a fraction, second column, third button down. We're going to do negative 42 plus square root. We get green button and then the square button. That'll give us the square root. And we can put in that 1,800. If you hit the down arrow, you can put over 2. And it gives us super gross answers. And that's okay. Sometimes our answers are going to be gross, and we're just going to take pieces of it. We're going to take our 0.213. And then we're going to go do the same thing, but subtract. Fraction, negative 42 minus square root of 1,800 over 2. And we get negative 42.213. Thank you. Okay, so we'll talk more about the quadratic formula later on, but we've seen it before in our algebra stuff. It's just been a minute. So I wanted to talk through it again. So our options when we have standard form are to do our factoring, if it's possible, to do the quadratic formula, or to put it into vertex form. If you do our vertex form, remember our negative b over 2a, and then plug it in, that makes it solvable with square roots. So that is an option as well. Not a common one, but it is an option. Okay, so I know this one's really long because the people who write the book are really annoying and they like to make choices. But questions on this one. I'm going to zoom it out so you can see the whole thing. Questions on any of these pieces? Okay. So, I don't know. I'm just looking at what we're doing next. Chill. Oh, okay. All right, so the next one on this page, it's almost identical, honestly. The only thing that's different is it's got a GCF. It's still obnoxiously unfactorable. It's still going to require us to do either quadratic formula or vertex form. So we're just going to go ahead and, not. It's so what?
It's so great.
Uh-huh. You, less than 6 feet from me. You really think I ain't gonna hear it, man? Come on. You even have the record going. I can't not address it. Dude, chill. All right. So, what I have for you now is we're going to look at page 95. And I want you, either in partners or in groups or whatever, to see what you think. There is a quadratic equation here. And I want you to see if the pigs are going to be hit. So there's a quadratic equation that's modeling an Angry Bird. They are, I think they wrote this book when Angry Birds was super popular because they are obsessed. I think I've even cut out 2 Angry Bird examples that they do in this book. There are so many Angry Bird examples that they do in this book right now. It's crazy. So they've given us an equation for an Angry Bird, because of course they did. And we want to see if the pigs listed at those heights are going to be hit. So what I want you to do is I want you to try and see what we get. So they're giving us the equation for some bird flight. Here's my chunky bird. There's a couple of pigs. And I want to know if pigs at certain heights, that is a demonic pig. What was that? Are going to be hit. So the information's on page 95. So I want to know if there's any chance that they're going to hit a pig at 45, a pig at 57, or a pig at 65. And how can you tell? So I want you to try that. Look at, it's page 95. See what we think. There's a few different ways you can approach this. I want you to try something. See if we can figure out if these birds are going to get hit.
Yeah, I have my permit. I can't get my license searches.
How about we look at these birds and pigs instead?
My driver's license.
I'm sorry. Do nothing again. Being annoying.
Our pigs are high, so
95, page 95. And I'll get it back up in a second. I gotta get a message.
I got like 12 hours. I'm being really stupid. But just date someone, just to give you a hint, or just to every single hour. I don't know, because they shouldn't be what's not driving every single day. I'm not doing it every single day. Whichever the first time, some of them do day and not night, and some of them do night and not day. You know what I'm saying? Yeah. And then whatever you don't, just put if you don't do it, just put in/. You know what that is? Not,
Are you just using your nail?
wait, so like if you didn't, oh, so like if you didn't do day put and then, oh, okay, that's what you
I thought so.
did. Did they tell you to do that? Yeah.
How are you doing it? You using your fingertips? That's crazy.
That back up here. I've set my thing.
I am. But like, I'm here like, thinking, look at how I did this. Oh.
So work together on this. Get to work together. It's time.
I got this.
Let's move into 25 and 16.
What could we do?
No, it's fine.
I believe Ashley doesn't know what she's I just found out yesterday. I called the mom. Can't do it. It's a lie. That's what I was referring to. That feeling I was referring to the weekend, and she was like, because I did the voice. At first, I didn't know that was me. I didn't know that was me. I don't know who made it.
What's up? Yes, the squared value is your A. Correct. So if it helps, rewrite it. We can rewrite this as h of t. Oh, sorry, zoomed in. Minus 16t squared plus 25t plus 45. Absolutely fine. You can absolutely rewrite it like this if it helps you. If I want to know if a pig at 45 can be hit, what would we do? How could we even start? Substitute it in for what? Not for B.
For H.
For H. If I want to see if the pig at 45 height can be hit, I don't know what that notation is, but there we go. We can substitute that in place of the height. I want to know if this is solvable. Can we get a thing? I'm gonna give us more space and then I'm gonna zoom it in. What could I do to try and solve this? Whenever we're solving quadratics, a good start is to set it equal to 0 first. So whether or not we were subtracting the 45 from either side, it's going to be fine. So when we're looking at quadratics, we're going to set it equal to 0. So we have 0 equals minus 16 t squared plus 25t. Remember, we're trying to solve to get to a t equals or an x equals. So what can we do here? We can absolutely factor this one. This one's doable. Huzzah! Finally. What can we do to factor it?
Take out the T.
Take out a t. So we're going to have our 0 equals t times minus 16t plus 25. It had a GCF of t. I always put that little loopy on my t because otherwise my t's look like pluses too hard. So my t's have the little loop on the bottom. If I was looking for a solution for what time it would hit there, how could I figure out my t equals from factored form? What are we going to do with each of our factors? Yes, set them equal to 0. So one of them's easy peasy because I've got 0 equals t. We like that. T is 0. That's an answer. Our other one is 0 equals minus 16t plus 25. How can I figure out what t is? Subtract 25 from both sides. So we're going to have negative 25 equals negative 16t. What do I do to get t by itself? Divide by negative 16. And what are we going to have on the left-hand side? It's like, is that a decimal we know off the top of our head? No. Utilizing tools. We can put it as 25 over 16. If you want it as a decimal, that's fine. It's going to be a little more than 1.5. What is it? Tell me what calculator, type it in.
Oh, no, I'm doing it like that.
So do 20. Well, that'll work too. What was it, tell me? 5.6. See, I wasn't wrong. A little over 1.5. If you're doing quadratic formula, it should still give you the exact same value. Just make sure we had up here. Here we have a C of 0. Okay, still works just fine. So then my question is, do we hit the pig at 45? Did we hit this pig? Why? Is this a valid time? Yeah. So did we hit a pig?
Yep.
Yep.
Wait, so like,
What would be things that would not work?
oh, like negative numbers?
So negative numbers will be that we had to travel back in time to hit it. Or if we straight up get like an error on the calculator, like a no solution situation, where we have the square root of like a negative number. If we try and do the quadratic formula and we get the square root of a negative, that's not going to work. That is not a real number. So we would not have a solution for that. So yeah, we hit at 45, but now we have kind of a blueprint where we can either factor or we can work quadratic formula. See if we're going to hit at 57 or at 65. Go take a peek at that. Now we have a blueprint. I felt like we got really stuck really fast on that one. So go see if we're going to hit the 57 or the 65. So 57 height, 65 height. Check those two. What's up?
Trying to type something in the calculator, keep saying domain error.
What are we typing in the calculator? Okay, simplify the under the square root first. See if that helps us see what's going on.
This is right.
So do it without the radical sign, so we can see what's happening. So just do the under, the 25 squared, our discriminant, minus 4 times 16 times 45.
Wait.
And then the square root of that.
Well, actually, you can, cause I thought you could, right? Yeah.
What would we get when we do that?
A negative.
Is a negative 1 squared still negative? It'd be positive. So what squared gives us a negative number?
What's cool is it's a negative number. A negative number. Right? Cause
Well,
two
I'm just saying-
negative numbers give us a positive base.
Correct? Correct? We're not working with them, but that's what you're getting stuck on. Okay, we want to, because we did do that.
Oh, I wasn't thinking about that.
We did do that. We're not done, but we did do that, so that that's why it's getting, you're getting an imaginary number. So, what were you looking for? For when? What was the height you were looking at? Mhm. For a problem that you did. What height were you looking at? You can put a 45 over here. What'd you do? You did.
Oh.
You did zero, right? You found the solution.
Oh.
That's not, I don't think that.
Which field was in head? Oh, you dropped the negative sign. Minus 16,
I don't, that's, I think
which makes a difference, because it will have a solution.
is.
Minus-
Oh my goodness.
Okay, that'll make a difference there, because it will have a solution, but,
Cause then it multiplies by the negative 4. Yeah.
so that'll fix that part.
Yes.
But then again, did we want to see where it hit the ground? Because you saw this is 0.
You're right, so it should be a 45.
45 is when we do this, so that's a step.
I mean,
So do 57 and 65. Pick one. Pick one. So you're setting it up right. Just silly mistakes.
yeah.
And if you get a domain error, that means we're dealing with imaginaries, and we're not dealing with imaginaries. So what do we think? Anybody get a hit on one of these? So we have one more option that I'm going to show you for solving. It's kind of a sheet mode. Oh. No. Oh, I don't have a keyboard over here.
It's weird.
There we go. So, is there any chance of me hitting a piggy at 65? Is there any chance of me hitting a little pig that is at 65 height with this equation? Why not? My vertex is under 65. My vertex is under 55. My vertex is right here. So we could find our vertex to look for that high point and see if those points would be underneath it. That would be another way to approach it. We could switch it into vertex mode and see where that high point is. We could also make a graph. We haven't done tons with graphing, but we do have access to digital software. Desmos is super awesome. We love Desmos. Okay, so we can hit 45. We saw that at time 0, and then at time slightly more than 1.5. This is where our 45 is. I can have a little piggy right here. Boom, boom. Look at, I'm going to find our keys. There's a piggy. It's about to be hit. 57, even if that pig is right here above the vertex, he's still getting missed. That one looks like an alien. Good enough, though. Maybe if I make him chunkier. There we go. Now it's a piggy. The little Angry Birds pigs, they're green. Okay, I know 65, that's way up here. We got no chance of hitting this guy. He's way up here. Okay, so we have lots of options when it comes to solving. There are many different ways, and there are going to be some ways that work better for your brain. And if you pick 1 or 2 methods that you can solve with, and that you can continually solve with, I'm okay with that. Okay? Whoa, that's not what I meant. What is this page? Oh, there we go. Okay, so on that note, there is a homework. It is page 97 in your book, and it is trying to solve things in as many ways as possible, whether it's square roots, whether it's graphing, whether it's factoring. It is the same problem, and I want you to try and solve it with as many different techniques as you can. Okay? You'll get the same answer each time, and it's a good way to kind of double check that we know how to do all of these. But that's what the homework, the next homework is. I think it's homework 5. Our unit test is March 27th, not 28th. That's cold. I continually forget to go in and fix that because the 28th is a short period. And we don't want that. We do not want a shortened period for a test. That is not good choices. I'm good. What's up? Okay. Yeah, send me the thing.